Ask My Instructor 2.2.21. Consider the behavior of the values of sine of 1 over x near x equals 0. In particular, what is the behavior of the function y equals sine of 1 over x as x gets closer and closer to 0 coming from the right? We will build a table to examine that behavior. In examining the behavior of y equals sine of 1 over x, we choose the values of x very carefully. I did not choose those values of x. My math lab did. If you see this problem in your homework, you'll see that they give you these values of x and they ask you to fill out the table. But why did they choose these values of x? Well, first of all, notice that the denominators are getting larger and larger and larger. So the x values are getting smaller and smaller and smaller. So I am looking at what the function is for smaller and smaller and smaller values of x. But they chose it very wisely. Look at what happens when I look at the reciprocal of, so they gave us x, let's look at the reciprocal 1 over x, because that's what we have to find the sine of. We're not finding the sine of x, we're finding the sine of 1 over x. So let's look at 1 over x. By looking at 1 over x, we're looking at the reciprocal of all of these values. Well, all of a sudden these values seem to be our best friends. Pi over 2, 3 pi over 2, 5 pi over 2. Those are very nice values for evaluating the sine. To calculate the values of sine of 1 over x, we now only need the unit circle. So we want to find what is the sine of pi over 2. This may not be at this time readily available in your head. It would be best if it was, but if it's not, I have a chart here, a unit circle here for you to look at. At pi over 2, you're here at the top of the unit circle. Sine is the second value of the ordered pair. And so sine of pi over 2 equals 1. And so sine of 1 over x, if x is 2 over pi, the sine of that is 1. How about 3 pi over 2? Well, 3 pi over 2 puts us at the bottom of the circle, and so we've got sine is negative 1. And I put that value into my table. What about 5 pi over 2? 5 pi over 2, if you know your fractions, 5 over 2 is the same as 2.5, right? So 5 pi over 2 means you go all the way around the circle plus another pi over 2. Well, that just means you end up at the top again. And so sine of 5 pi over 2 is 1. And I put that value into my table. How about 7 pi over 2? Again, knowing your fractions helps. Let's so 7 is the same as 4 plus 3. So this is 4 pi over 2 plus 3 pi over 2. Well, 4 pi over 2, that just means you're going around the circle once. So 7 pi over 2 lands you at the same place as 3 pi over 2. And the sign there is negative 1. And so I get negative 1 for 7 pi over 2. Well, we continue this song and dance for 9 pi over 2 and 11 pi over 2. You just keep going around the circle. All of these values will land you either at the top or the bottom. And these are the values. So you see how it's 1, negative 1, 1, negative 1, 1, negative 1? And this is happening as I get closer and closer to 0. we can see that the value of y equals sine of 1 over x oscillates between 1 and negative 1 as x gets closer and closer to 0. In fact, the alternation between 1 and negative 1 happens infinitely many times on the interval 0 to h, no matter how small h becomes. This is kind of a wild function. Therefore, we say that the limit does not exist due to oscillation. Now let me see if I can bring you back up to the picture that we had at the very beginning. See if I can find that slide for you. Oh yeah, here it is. Okay, you see how as we get closer and closer to 0, that oscillation just happens faster and faster. And so the value sine of 1 over x, it never settles. It never settles. It just bounces between between 1 and negative 1 for faster and faster and faster. So the limit doesn't exist. Have a great day. Let me know if you have any questions.